This problem is for chi-square test of homogeneity. There is a lot of information on one page. I will keep writing and then move the page up. So now we may be a good time to take a screenshot. So we start from one problem statement, and then there is a question. They give you an observed frequency table. This is a two-way contingency table. There are two variables. The first one is gender. The second one is pet preference. So let's say out of 1,000 people, 200 of them are female, they prefer to have a dog, and then 140 out of 4,000 people, they are female, and then they prefer to have a cat, and then 28 of them are male, and then they prefer to have other pet, and then 63 are female, and then they prefer to have no pet, and then we have a row total. This is a row total, and then for each column there is a total, and then you can add the column total and the row total either way to get a table total or a grand total. That is how a two-way contingency table works. And then the observed frequency table is data, is a real data. So you go outside, you collect data, you ask people question, you record the response, and then you collect data. And then the expected frequency table, this is for computation. So we need to compute every single one of this based on our data. So for the first table is observation. The second table, you got that from computation. Okay, so this problem statement is simply saying that there are 1,000 people, and then 56 female, and then 440 male, and then you ask them their pet preference. And then the question is, does the same proportion, so let me repeat this one more time, does the same proportion, okay, just keep this word in mind, does the same proportion, actually I can highlight that for you, does the same proportion, okay, does the same proportion, that is the keyword, does the same proportion of females as male prefer each type of pet, the significance level is 5%, that means the alpha is equals to 5%. Okay, let's make an observation based on the data. So what do you see in this table? So in this table, I see that there are two variables. Okay, and then the first one is gender, and then the second variable is preference. And then what is the dimension? They don't say the size. They use a fancy word, dimension. What is the dimension? The dimension, this is extremely important. The dimension is 2 rows by 4 columns, right? Okay, 2 rows by 4 columns. Okay, so the total don't count. 2 rows by 4 columns. What is 2 rows by 4 columns? 2 rows means gender has female and male, and then 4 column is for preference. All right, and then what else? This one, the question, does the same proportion of male as female? What does that mean? The same proportion. Same proportion means homogeneous. So this same proportion is saying one thing, homogeneous. So this same proportion is saying homogeneous. That means the same. So usually in short, the H0 and HA is the H0. We say that the proportion of females and male naming each pet preference are homogeneous. So that means we just take the question, does the same proportion? We say yes, the same proportion, homogeneous. And then the HA, we will take the opposite, which is not homogeneous. All right, then we have H0, HA, we have the dimension, we have all the data, and then what is the next step? The next step is we have to compute the expected frequency. Okay, compute the expected frequency. Okay, I will just show above. I will just show a few, and then I will give you the rest because it will take a long time to just handwrite every single one of this. Okay, let's say I want to get this one. I want to get this data. How do I get it? And then this is a row 1, column 1, right? Okay, so I am going to say expected frequency from row 1, column 1. And then this one, I will take the column total, multiply the row total, row total times column total, or the other way around because it's multiplication. I will say row total multiply a column total and then divided by the grand total. This one you do need to approximate. I have 232, so this one is 232. Okay, let me do another one. So this time, how about I do I try the female and other pet, and then this is expected frequency row 1 column 3, and then we are using this row, column, and then grand total. So that is a 560 multiply 60 divided by the grand total 1000. And then this is equals to or approximately equals to be precise, 34. All right, I'm going to erase this mark and then put a 34 right here, 34. And then I believe that I should do one more or two more. How about we do a male and no pet based on the 57. So we have a row total, column total, and then a table total. And then this is a expected frequency row 2 column 4. That is equals to 440 multiply 120 and then divided by 1000. And then this is approximately equals to 53. This one, if this is your first time doing computations like that, I highly recommend you to just do the calculate the frequency one by one instead of using a graphing calculator. So you run the test and then you got all the numbers. So because that enhances your learning experience. Writing everything one number at a time is better than just use a calculator to get everything in one time. And then I want to do one more. How about we do we try this male cat. Okay, that is expected frequency row 2 column 2. Okay, so go to the data and then let me erase these marks, and then we are based on this one 405 and 440. So that is the row total times the column total 405 and then divided by 1000. And then this is approximately equals to 178. So that is approximately equals to 178. So I will do 178. And then for the rest, okay, I did 4 for you. Oh, where is my 53? This is my 53. Okay, I did 4 for you. And then for the rest, I will just give you the numbers. So let me give you the rest of the numbers. I highly recommend you to just practice the rest by yourself instead of just taking the numbers from me. This is a 183. So when you add them, and then this is equals to 415. And then this is a 227 female and cat. Add the 178, you get the 405, and then male other pet, this is a 26, add them, 60, female no pet, 67, add them, and then 120, and then you add each row, you will get a 560 plus 440, that is equals to exactly 1000. So right now, we have a H naught. The proportions are homogeneous versus HA not homogeneous, and then we have an observation from the real data, expectation from computations. And then the next step is we have to calculate the chi-square statistics. Okay, for right now, I think if you are still catching up, this is a good this is a good place to take a screenshot. Did you get it? Okay, then I will move up my page, right? So I will move up, and then we will do the chi-square test statistic. This is not X. This is a chi-square. Chi, this is called chi, CHI, and then chi-square, not X. Chi is a Greek letter. That is equals to summation. This is sigma. Sigma means summation in mathematics. And then open parenthesis, O minus E means observation minus expectation squared divided by expectation. And then what we have to do is we take the 200 minus the 232. So that is a 200 minus 232 square divided by 232. And then we have to do this for every single joint frequency. So we have 2 by 4. That means we have 8 of this. Okay, 2 by 4, 8. And then the next one, 232, I will need to erase these two circles. And then the next one, let's do the female and cat. So that is a 265, 227. 265 minus 227, and then divided by 2 over the 227. And then plus the next one is other pad, 32 and 34. So that is 32 minus 34 square divided by 34. And then the next one is notepad, 63 and 67. Allow me to erase this mod really quick. Actually, this one. Okay, so that should make the table easier to read. 63 and 67. Okay, so 63 and 67, and then plus 63 minus 67 square divided by 67. And then the next one, 215, 183, and then plus 215 minus 83 square divided by 83, and then plus 140, 178. Okay, and then the next one, 28, 26. Divided by 26. And then the last one, 57, 53. And then plus 57 minus 53 square divided by 53. And then, okay, let's say we are not running a test using a chi-square test using any software. Okay, for this kind of computation, you can do this by using a graphing calculator. I know, using a graphing calculator, but we are not using a chi-square test to get all the numbers in a few clicks. We do all the computations by hand, but we are using the calculator to get this kind of computations for us. And then this is equals to 25.6586. And then this is called a chi-square test statistic. Okay, chi-square test of statistics. And then we have to compute a degree of freedom. Degree of freedom is equals to the number of rows. So we have 2 rows minus 1, and then you multiply the number of columns. You have 4 columns minus 1. This is 1 times 3 is equals to 3. Okay, 1 times 3 is equals to 3. And then now, to calculate the p-value, this time we will have to use, I will say I will be using a graphing calculator to do it, but if you are using R, or you are using a Minitab, you are using Excel, there is a way to calculate this chi-square. So what the chi-square means is we have an xy plane. So we have an xy plane, and then we draw a chi-square graph that starts at the origin, and then the chi-square graph looks like that. And then this one is 25 something, right? So this is a 0. 25 is very far away from 0. So it is like right here. This is a 25.6586. And then chi-square is always right-sided. So that means we are shading this region. The p-value is referring to how big this region is. Okay, like I said, there are so many ways to do it. You can do this in Google. You can do this in Excel, SPSS, Minitab. You can do it in R, but I will just do it in a graphing calculator because I've assumed that you cannot bring a calculator to a stats exam. Okay, so what I am going to do is I am using a graphing calculator. So what I will do is I will do this. I will go to, I will press this key. I will press the second key, TI-84 graphing calculator, second, and then I will press vars. And then I will go to chi-square, CDF, not PDF, CDF. PDF is finding a specific point on the graph. We don't need that. We need the area under a graph. The CDF represents cumulative density function, meaning that you are looking for area under the graph. Okay, if you don't know what cumulative density function is, CDF means, okay, that means I am looking for area under a graph. And then the command is chi-square CDF. Okay, you have to input 3 values. The first one is your chi-square test statistics, 25.6586. And then the next one, you start from this mark and then you go all the way to the right? So you go all the way to positive infinity. So the way I type positive infinity for myself. Oh, by the way, if you are using a newer version of graphing calculator, the TI chi-square CDF, they have a menu. they are asking for a lower limit and then an upper limit. The lower limit, you will type 25.6586. Okay, I am looking at my calculator right now. And then the upper limit, the positive infinity, you can either type a really large numbers like that, or if you want to be professional, you can type 1 times 10 raised to the 99 power. The way I do this is, listen, I click 1, and then second comma. Where is the comma key? The comma key is right above 7. And then I type 99. 1 second comma, you get the E, and then 99. And then you have a degree of freedom. And then what is that equal to? This is approximately equals to, and then let me type my degree of freedom, and then I got 1.12433.095, and then I see a E to the negative 5. This video, I won't show any calculator screenshot. I would like to do that in a separate video, so that won't make the video too long. What I see is, okay, allow me to just change that to an equal. This one, they gave me a 1.12433.095 and then E negative 5. That means this is approximately 1.12. I keep 2 decimal places times the E is a base 10. The negative 5 is a power. So when you see this, that means this is so small. This is just less than alpha. Your alpha is 5%. That is given 0.05. So this is your 5% alpha. They gave you that. Do you see that? The significance level is 5%. The significance level is 5%. 0.05. This p-value is the same thing as the area of this region. 0.05 is way bigger than that. If you want to see that on the graph, I will say this one is around 0.05. So this region is around alpha equals to 0.05. And then since the p-value is inside of this, is inside of the rejection region. The alpha, you can call this a rejection region. You have a p-value inside the rejection region. That means you will reject H naught. So what you will do is, you will say, I will reject H naught. Reject H naught means we believe HA. I trust HA. I trust HA. Okay, so if you want to report a complete sentence, because when you are working in a job, you cannot say, okay, reject H naught, we believe HA. Okay, let's say somebody who never took a stats class, and then they will ask you, hey, what is H naught and HA? Okay, so this is reject H naught, and then we believe HA is for a statistician like you, right? But for non-statistician, you have to say something that everybody understands. Then I will just say, we believe HA, it appears from the sample data that males and females in that college have different preference. What is different preference mean? Different preference means not homogeneous. Because the HR is homogeneous, HA must be not homogeneous. So we believe HA, then we have to say have difference preference. That means not homogeneous when it comes to selecting a pet. All right, then that finished the problem. So we have reject H naught, we believe HA, we got the p-value, and then the computation to get the chi-square, the computation to get the expected frequency, and then we started from this problem. Okay, this video, I will just not introduce the calculator, any calculator screenshot. I will just do that in a separate video to not make this video too long. All right, I will just end the video right there, and I will see you all in the next one.